Hello students, this video lecture will cover section 9.1, Translations. Our learning goal for this lesson is to identify isometries and to find translation images of figures. So let's start with the vocabulary. A transformation of a geometric figure is a change in the position, shape, or size of the figure. In a transformation, the original figure is called the pre-image, and the resulting figure is called the image. An isometry is a transformation in which the pre-image and the image are congruent. So in this case, three words that you're probably familiar with are flips, slides, and turns. So using the vocabulary that we just went over, question number 1 asks us to identify an isometry. So the question is, does the below appear to be an isometry? So as we look at these two figures, we have a pre-image and an image. So after some transformation, this pre-image has become this image. So you can see that there's a definitive change in size between these two. And for that reason, this is not an isometry. And that's because, again, there is a change in size. Looking at the second set of figures, we have a pre-image here and its image over here. And I would say yes, these do in fact look congruent. And this is likely either a flip or a turn. So a transformation is in fact a mapping from the pre-image to the image. And usually we use this arrow notation to identify a mapping. A little bit of new notation here. Sometimes prime notation may be used to identify image points. And so we read this as triangle JKQ is mapped to triangle J prime, K prime, Q prime. So problem 2 asks us to name the images and corresponding parts. So we have a diagram here where E prime, F prime, G prime, H prime is an image of EFGH. So two quadrilaterals here. And we're asked, what is the image of angle F? So you can see here, this is our pre-image, F, and its image is going to be the same location. And so the image of angle F is going to be angle F prime. And so the pairs of corresponding sides, it's going to be positional. So EF is going to be mapped onto E prime F prime. And each pair works the same way. So FG is going to be mapped onto F prime G prime. We're going to have GH, which is mapped onto G prime H prime. And then finally we're going to have EH, which is going to be mapped onto E prime H prime. So this lesson actually covers translations. So a translation is a transformation that maps all points of a figure the same distance in the same direction. And a translation is an isometry. So remember that two figures after a translation will still be congruent. And so this notation here tells us that the distance from A to A prime is the same as the distance from B to B prime, which is the same as the distance from C to C prime. And so this is maintaining the same distance on each point. So question number 3 asks us to find the image of a translation. So we're given triangle PQR, and we're asked to use a translation rule. So you can see here we're being told that all the points in triangle PQR, every point x comma y should be mapped to x minus 2 comma y minus 5. So let's take a look at point P. In the original triangle, point P is at 2 comma 1. So after it's been translated, we should find that this goes to 2 minus 2 from the translation rule, and 1 minus 5 also from the translation rule. So we get that P prime is going to be located at 2 minus 2, which is 0, and 1 minus 5, which is negative 4. So if we go to 0 and then go down to negative 4, we'll see that this is P prime. So Q, we can look at the figure and we can see that Q is at 3, 3. And after translation, we're going to have 3 minus 2 and 3 minus 5. So Q prime is going to be located, 3 minus 2 is 1, and 3 minus 5 is negative 2. So we have 1 comma negative 2, and we find Q prime is going to be located right there. Now, 2 points is probably enough here because once we connect these 2 points, we have to remember that translations are isometries. So they maintain the same exact shape. So in order to find R, we can actually use Q as a reference point and just go 1, 2, 3, 4 to the left of Q prime. So 1, 2, 3, 4 to the left of Q prime, and so we can find R prime in that way. And so we can connect R prime to Q prime and R prime to P prime, and there's our triangle. And so if we want to write a rule to describe the following translation, we're going to write the rule similar to the way we've just seen it. So the translation image of triangle LMN is triangle L prime, M prime, N prime, where L prime is at 1, negative 2. So we have 1 comma negative 2. So that's going to be the location of L prime. And you can see from here that M prime 3, negative 4 is actually going to be off our grid. It's going to be over here somewhere. And then of course N prime is going to be way over here somewhere. But this is actually enough because we can see that the L to L prime, we're going to go down a little bit and then we're going to go right some. So what we want to do is we want to figure out how to get L, which is currently at negative 6, negative 1. And we want to figure out how to get to that L prime, which we're told is at 1 comma negative 2. And so to get from negative 6 to positive 1, we're going to have to take x, and we're going to have to get x to plus 7, so x plus 7 over here. So then to get from negative 1 to negative 2, you can see that we're going to take y, and whatever it is, we're going to take y and subtract 1. So this is what I think the rule should be. Now the best way to check that is to actually try to apply it to another point. So let's take M. So M we know is currently at negative 4, negative 3. If we add 7 to negative 4, we would take this to M prime. Adding 7 to negative 4 would give us 3. And if we take the negative 3 and subtract 1 from that, we'd get negative 4. And so if you compare this to what we got from our rule, you can see that the rule is in fact correct. So sometimes we do more than one thing at once. So a composition of translations is a combination of 2 or more translations. So here, problem 5, composing translations. The diagram at the right shows 2 moves of the black knight in a chess game and asks us where is the knight in relation to its original position. So this first translation we could say move left 2 up 1. So left 2 and up 1. And then from there we'd say up 2, right 1. Now if we were to write this a little bit more mathematically, we would say that x comma y, now x is a horizontal movement, So we wanted to move left 2, so we'd say x minus 2 here, and then we'd take y and add 1 to that. Our second translation would take x comma y. We wanted to go right 1, so we're going to take x and add 1 to it, and we wanted to go up 2, so we'd say y plus 2. So if we take the negative 2 and the plus 1 and combine them, we'll find that what we really want is x minus 1. And if we take the y plus 1 and the y plus 2, we end up with y plus 3 if we combine them. So what we can do is we can take these and actually kind of add them together in a way to say that the composition of the two translations takes us to the left 1 and up 3. So if we go left 1 and up 3, we end up where we were after the two movements of the knight. And so that completes this video lecture on section 9.1, translations. Hopefully we're now able to identify isometries and find translation images of figures. Thanks for your time, and I'll see you soon.